6.0 day 1 is talking about multiplying and dividing monomials and properties of exponents. So the first thing that we're going to do is talk about what a monomial is. So a monomial is a number, variable, or combination of both with multiplication and or division. Now the big thing is no adding and subtracting allowed. Okay, so monomial examples would be like 3x to the 5th, or x to the 0, or a, b, c, d, and you could raise d to the 4th, or whatever you can think of. Okay, but it's one term, right? Some non-examples would be something like what we've been dealing with, like 3x plus 10, right? Those are two terms. This is one monomial. This is a second monomial. Okay. Monomials are things like constants or numbers like 15, right? That is a monomial. It's just one term. Okay. So other examples, you can also have variables or numbers in the denominator. So you could have something like that, or you could have 15 over x to the 5th. These are all still monomials. Okay. As long as you don't have an adding or subtracting, like a plus b plus c d to the 5th, things like that. Okay. As soon as you start seeing pluses or minuses, it becomes a non-monomial. So let's talk about the first property that we're going to work with. So the first property is the product of powers. So if you think about these, y to the 3rd times y to the 7th. Y to the 3rd is really y times itself 3 times. But then y to the 7th would be y times itself 7 times. If we combine those, you'd have the 7 and the 3 to have y to the 10th. Our multiplying powers, that have the same base, you add the exponents. Okay, so these are all called powers. So anytime you have y to the 3rd, x to the 100th, okay, anything that has an exponent, those are called powers. And when you're multiplying powers, you are adding the exponents. So if we have a to the m times a to the n, that would be to a to the m plus n. So some examples off to the right. We have x squared times x to the 4th. So we would add those. That would be x to the 2 plus 4, which is x to the 6th. On the next one, we are going to multiply each thing individually. So keep in mind, 2 times 3, you're not automatically adding these now. It's still just 2 times 3. So that would be 6. And then you have a to the 3rd times a to the 3rd gives me a to the 6th. Okay, again, we would have 3 plus 3. And then y to the 3rd, y to the 4th, we would add them for y to the 7th. If you move on to number 3, take a second and think about what you would need the question marks to be in order for it to equal what it's supposed to equal. So in number 3, the question mark would have to be a 7, right? This would have to be z to the 7th because I need 9 plus 7 to equal 16. And that's the only option. For number 4, you could come up with a couple different things, right? You could have w squared times w to the 9th. You could also have w to the 3rd times w to the 8th. You could have w to the 4th times w to the 7th, and so on, right? You could have 6 and 5. And you can also have 1 and 10. Right? Remember, if there's no power written there, it is a 1. Okay, and you can have these in any order as well. As long as added together, it equals 11. So our next part of today is talking about quotient of powers. So same situation here. If we have a to the 12th, that means that we have 12 a's. If we have a to the 8th, we have 8. Now we can think about, okay, well, how many of these would cancel? So we cancel them this way. This is hard to do. And you're left with just 4 in the numerator. Now, I want you to think about doing what we just did, right? We have 4 left over in the numerator because the 12 is bigger than the 8, right? So you're going to have leftovers where the larger number's at. So when dividing powers with the same base, you subtract. Right? Think about it. 12 minus 8 gave me 4. So on the bottom part, a to the m over a to the n, that would be a to the m minus n, assuming that m is larger than n. So let's look at example number 5. So this one's b to the 5th over b squared. So I'm going to take 5 minus 2, just big minus small. 5 minus 2 is 3. And that 3 goes where the larger one's at, which is in the numerator. That's where the leftovers are. If we look at number 6, right, for your m's first, m to the 7th over m, remember if there's nothing, it's a 1. So 7 minus 1 is 6. And that goes in the top in the numerator because of the fact that the 7 is larger than 1. Now in the next one, n to the 5th over n to the 8th, we're going to do 8 minus 5, which is 3. Where are the leftovers at? In the denominator. It's where the bigger one is. So then we have ones like number 7. Okay, same deal happening here. We're still doing big minus small. So a is 10 minus 3, which is 7. It goes in the numerator because that's where the larger one's at. Don't let the next one confuse you. You're still doing 3 minus negative 2. Remember, when you are subtracting, when you're subtracting a negative, you're really adding. So it's 3 plus 2, which is 5. Now, where does that go? Where the larger one's at. So b to the 5th would go in the numerator, which means we have nothing in the denominator. So you could put a 1, or you could just keep it as a to the 7th, b to the 5th, and that's it. So find some values, just like we did above. Think about what these numbers have to be in order to get the final answer. Okay? Or in number 8, describe what is happening as the mistake here. So take a second. So on number 8, okay, I need to subtract 15 from a number and get a to the 7th in the numerator. So essentially what we would do is take 15 and add 7, right? And so our a to the question mark would be 22, because 22 minus 15 gives me that 7. In the next one, in number 9, hopefully we recognize that this final result was incorrect. And the reason why it's incorrect is because when dividing powers, you subtract, not add. We have one more concept of the day today, which is a pretty easy one, and that's zero exponents. Okay, this is the big one. Any number raised to the 0 power equals 1. 5 to the 1st, because that's still 5, right? So I need something different than a 1, which means in order to get it to be a 1, it would have to be a 0. Okay, and if you type it in your calculator, 5 to the 0, it would come up with 1. Okay, so that's part of our as part of our examples. If we had something like 2x to the 3rd y to the 0 power, that would be 1, because everything's being raised to the 0 power. Okay, anything with a 0. What I do is I just cross it off because it's like multiplying by 1, which means it goes away. Okay, so let's talk about a couple examples down here. These get a little bit trickier, and we're going to have to clean some things up and work through them together. Okay, so you have two options when multiplying these fractions. You can think about them as one big fraction, because remember, when you multiply fractions, you multiply straight across, right? And you could just start canceling them. Okay, so I'm going to start canceling individually here first and seeing what I can come up with, and then including the right one. So I know that I have these x's that I can cancel. So I know I have x to the 5th in the denominator, right? Because 10 minus 5 is 5, goes where the larger one's at, okay? And I'm going to think about these as two separate fractions right now. Next one, y to the 4th over y. Subtract them, you get 3, goes in the numerator because that's where the larger one's at. Now the things that I do want to work with are the 3, 2, 6, and 4. I'm going to start trying to cancel them now. And the 2 can become a 1, and the 6 can become a 3, right? Because 6 divided by 2 is 3. So now I know in my numerator, I'm going to have a 3 as well over here. And we can start cleaning up this side. Now really the only thing that's happening over here, we still have the 3 and the 4. We still have the x to the 3rd, but we have these y's, which gives me 1y in the numerator, because 2 minus 1 is 1, goes where the larger one's at. So now we can think about it as one big problem. Focusing on the numerator, 3 times 3 gives me 9. Then we have y cubed and y, which becomes y to the 4th. I also have x to the 3rd and x to the 5th in the denominator. Remember, we're going to subtract them. We have 2. Goes in the denominator because that's where the larger one's at. The 4 is also down there, so we're going to leave it just like this. Okay? Let's look at number 11. But as of right now, okay, we just have two things being multiplied. So I'm going to focus on negative 2/3 times 12. Well, that gives me negative 24, and negative 24 divided by 3 is negative 8. So we have negative 8. Then we have x to the negative 3rd, x to the 8th. Negative 3 plus 8 is 5. And then we have y to the 5th time, or plus 0, right? So that just stays y to the 5th. And that's because, like I said, normally I just cross off anything raised to the 0 power. Final answer, right there. Number 12. All right. So at this point, again, there's not many fractions. We can just start trying to multiply the things that we need to multiply. So 5 times negative 1/10 would give me negative 1/2. Okay, it doesn't matter how you write the negative 1/2. You can put the negative wherever. Oops, sorry. So then we have x to the 4/3 times x to the 2/3. Now again, remember, we are adding. So we have 4/3 plus 2/3, which would give me 6/3. And 6/3 is really 2. So that becomes x squared. Then we have z squared times z to the negative 2, which would give me z to the 0. Now, we do not want to have z to the 0 in our final answer because that is 1. So our final answer, negative 1/2 x squared. And you could write it this way. It's probably how I will write it. Or you could write it negative 1/2 x squared, just like we did. Okay, same thing, same exact thing. Number 13. Again, piece by piece. So we're going to start with this first part. Negative 6 divided by 36. That gives me a negative 6. But that's a negative 6 in the denominator because that's where the bigger one's at, right? That's the reducing of it. We have a to the 7th over a to the 6th. Subtract them, we get 1. It goes in the numerator. B over b, cancel. You're left with b to the 0, which we don't want to write. And then we have c to the 8th over c to the 12th. Again, we want to subtract them, and we get 12 minus 8, which is 4. But this time, the 4 is in the denominator because that's where the larger one is at. We have one last one. Number 14. Something entirely being raised to the 0 power. Hopefully that is a big thing for you right off the bat, right? Anything raised to the 0 power is 1. So essentially that part just becomes 1, or it goes away. So the only thing I actually have to do is simplify this. So I'm left with y to the 6th, because 14 minus 8 is 6. Now that does go in the denominator along with the x to the 6th. Now, because we have nothing else to put in the numerator, we're going to put a 1 as a placeholder.